Hello friends, welcome to electronics lecture. Uh, Here we are doing introduction to bipolar junction transistor, that is BJT. This work is being done by VK Lectures and SP Academy.
So bipolar junction transistor, it's an electronic device. Now mainly used for amplification and switching purpose. Electronic device. Now what it has? It has got three terminals. Terminals are called collector, base, and emitter. Only for bipolar junction transistor or BJT. You call it as BJT. Now, what is this bipolar? What does this indicate? Bipolar means two poles. Now, this indicates who is taking part in conduction. Bipolar. Both electrons as holes. See, we have seen for a diode or for a semiconductor, there are two types of conducting materials. That is, one is electrons and another is holes. Both these electrons and holes are present in this BJT. So the conduction is done by either electrons or holes. Okay. Now you may hear about UJT, unipolar junction transistor. That is, only one, either electrons or holes will come. Here both electrons and holes are there. So this is bipolar. Now this is bipolar bijunction. Two junctions are there. Bijunction transistor. Two junctions. Bipolar bijunction transistor. Or simply bipolar junction transistor. Two junctions. That is, it is just like this semiconducting material. This is emitter, base, collector. Okay. There are two junctions. One is base emitter junction and another is this junction. Another is base collector junction or collector base junction. Two junctions. So that is why bijunction. Now what is this transistor? Transistor means transfer of resistance or voltage. See, when a current flows through small resistance, current I is flowing through small resistance, let it be called R small. So the voltage will be V small, right? Because the resistance across which this current is flowing is small. Now, when it is moving through higher resistance, the same current is moving through higher resistance R max or R high, you can write R high. So you have I into R high, which is high voltage. So this is what we are doing. We are giving a small signal with a small input resistance, and across the output we are getting a high output. Okay, this is what transistor used in amplifier circuits tells you. Mobility of these electrons. Mobility of electrons is high. That means it can move through the crystal diodes quickly. That is why in most of the time we will use NPN transistor than PNP transistor. This was also one of the questions asked for interviews. Why NPN is preferred over PNP? NPN is preferred over PNP means the resistance offered by the crystal to the electron is less. Resistance offered by the crystal to electrons is less than holes. That means when holes move through the crystal, they offer high resistance The crystal offer high resistance, but not to the electrons. Not much to the electrons. That is why NPN is more preferred. NPN means what? Electron majority carrier, holes majority carrier, electron majority carrier. So 2 out of 1. Who wins? This NPN wins. Okay, so that was another point to be noted. See, the color that I have given is based on the order of their doping. The base is least doped, and then comes collector, moderate, and the emitter is highly doped. Okay, now the area covered by this emitter, base and collector are also given in this picture. Collector is having the largest area. Collector area according to area, or according to width, you can say width of the collector is the largest. Largest for this collector. Then base is having low width. Width is low for base. For emitter, it is moderate width. So when you draw this, please take this into consideration. You need not color it now. You can color it later. But width, please make it a point you assign it correctly. So once again, the collector width is larger than base and emitter. Base is the lowest, then collector and emitter. Now this is the NPN transistor circuit symbol for NPN, N, P and N, and this arrow mark indicates direction of current. If it is towards out, that means from the collector. So this is NPN transistor. The arrow mark outward. Okay. So here PNP transistor, arrow mark inward. Now this is collector, base and emitter. Here also collector, base and emitter. Now both the collector current will be inwards. Collector is IC, base is IB. So IB plus IC equal to IE. IB plus IC is equal to IE. The current, total current IE. Okay. Now here also for NPN transistor also this equation is valid, but the direction of current will be in opposite. IE is into the transistor while IB and IC are out of the transistor. IB and IC are out of this transistor. In both way, this equation is satisfied. IE equal to IC plus IB. Yeah. So how to get this arrow mark? See, from positive to negative, the current flows. Okay, the current flows from positive to negative. That is why here you have a arrow mark towards the N region. And while for a PNP transistor, the current flows from this positive. This is positive, negative towards in this side. That is why arrow mark is towards the base. Okay.
Here we can identify the state of a transistor depending on the biasing condition for junction 1 and junction 2. Junction 1 is base emitter and the junction 2 is collector base. Now if junction 1, that is base emitter, is forward biased and junction 2, which is collector base, is reverse biased, then our state of the transistor is, or the transistor will be in the active region. Similarly, if it is junction 1 is forward biased and junction 2 is forward biased, it becomes saturation. That means transistor is in saturation condition. Now for if junction 1 and junction 2 are reverse biased, then it is called cutoff region. That means the transistor is in cutoff region. Likewise, we have if junction 1 and junction 2 are in reverse biased and forward biased respectively, it will act as a switch. Depending on the types of configurations, we have common base, common emitter and common collector configurations available for transistor working.
So this is IB into and IC also into this transistor. This is an NPN transistor, NP and N transistor. Okay, so we can start with our basic knowledge of current. IE is equal to IB plus IC. Now why it is given VBE? You can write VBB also, VBB, or you can write VCC. Okay, sorry, not VBB, this is VEE, because your voltage is across this end emitter. So because base is you have taken as common, so VEE. If this resistance is not there, you can take it VEE. The resistance is there, it is voltage across these 2 points. Now VCC means if there is no resistance, RC. Okay, now I can write IC is equal to alpha times IE, alpha times IE. That means IC is part of IE. That means alpha times IE plus IC naught. This is reverse saturation current. This IC naught is reverse saturation current. Okay, reverse saturation current, negligible value this one. Okay, now so you can write IC is equal to alpha times IE. And what is this alpha? That is current amplification factor for common base configuration. Alpha is nothing but current amplification factor, amplification factor for common base. Now what we can write? Alpha is equal to IC by IE. The value is around 0.95 to 0.98. That means maximum current. Okay, almost IE will be almost equal to IC. Not very similar. There will be, because IB will be order of this microampere. Both of them are in milliamperes. The current through base is very small. Okay, so if current through base is comparatively very small, IB will be almost equal to IC. See, this is NPN transistor because emitter region out. Okay, now this emitter region ആണ് E. This is base and this is collector അല്ലേ. അപ്പോൾ എന്ത് സംഭവിക്കുന്നത്, ഈ കളക്ടറിലോട്ട് പോകുന്ന കറണ്ട് പ്ലസ് ഈ ബേസിലോട്ട് പോകുന്ന കറണ്ട്, ദാറ്റ് ഈസ് ഐ സി പ്ലസ് ഐ ബി ഏതിലോട്ട് പോകണം? കറണ്ട് എവിടെയും സ്റ്റോർ ചെയ്ത് വെക്കില്ലല്ലോ, ഇങ്ങനെ പോയി കഴിഞ്ഞു, ഇങ്ങനെ പോയി, അപ്പൊ ഇവിടുന്ന് ഇങ്ങോട്ട് പോകാൻ പറ്റില്ല, അപ്പൊ ഈ വഴിക്ക് പോകും. അപ്പൊ ഐ ഇ ഇസ് ഈക്വൽ ടു ഐ സി പ്ലസ് ഐ ബി. ഓക്കെ, അപ്പൊ ഇവിടെ വി ആർ ടേക്കിംഗ് എ മേക്കിംഗ് എന്താ ചെയ്യുന്നത്, ഈ ബേസിനെ കോമൺ ആക്കി എടുക്കും. കോമൺ മീൻസ് കോമൺ ടു ദിസ് ഈസ് ഇൻപുട്ട് and this is output, common to both input and output. Input no output no common ആക്കി എടുക്കും. Okay, so that means we will be using voltage across emitter and base. Emitter and base ൽ ഒരു voltage ഉണ്ടാവും, collector and base ലും ഒരു voltage, and across this collector we will take the output. Okay, now you know that value IE, maximum current IE is equal to alpha into this IC value equal to alpha times IE. Based on the current whatever we are getting is alpha IE. In terms of IE we are writing. Okay, IE is part of IC അല്ലെ. കറണ്ട് കൂടുന്നതും ഇവിടെയും IEയും കൂടുമല്ലോ. അപ്പൊ എത്രമാത്രം കൂടും എന്നുള്ളത് is determined by this value. This IC naught is a very small value because it is reverse saturation. After saturation there is a small minute current flowing. All right, ഏതാ മനസ്സിലായില്ല? പ്ലസ് IC naught, IC naught, IC 0. IC 0 collector current തന്നെയാണ്. collector current, this is collector current but in reverse saturation when it is but very small. എന്തുകൊണ്ടാണ്? due to minority carriers. Okay, so we can write, neglecting this, we can write IC is equal to alpha times IE, which means alpha is equal to IC by IE. This value is around 0.95 or 0.98 alpha value, and this alpha is called current amplification factor in common base. This is common base ആണ്. So alpha is equal to in common base current amplification factor. Current amplification factor. Now from this you can find out IB also. What is IB? IB is equal to IE minus IC. IE minus IC. Now what is IC? Alpha times IE. So IE minus alpha times IE, that is equal to IE into 1 minus alpha. So you see this will be only 2 or 3% of the total current. 1 or 2% of the total current is nothing but IB. So this is IE, this is IB, this is IC. IC is equal to IB plus IE is equal to IB plus IC. Now this is, since it is base, we can write VBB, and emitter is common. Emitter is common to both input and output, and this particular value is VCC. Okay. Now same application you can use. IC is equal to alpha times IE plus IC naught. We will neglect this value. IC naught can be neglected. Now then just substitute this value IC equal to this particular one. So IE is equal to, or you can write IC by alpha. Taking this value, we need IC is equal to, IC is equal to alpha IE. So IC is equal to alpha into, what is IE? IE is nothing but IC plus IB, right? IC plus IB is nothing but IE. So IC is equal to alpha into IC plus IB. Now IC into, or IC minus alpha IC is equal to alpha IB. Now you can write IB, current IB is equal to IC into 1 minus alpha divided by alpha. IC into 1 minus alpha by alpha. Now we have written IB and IC. So here is your IB base, IB, and here is your IC. In terms of IC, so IC is your output, and IB is your input. So in terms of input, we are getting output. So IB, I can write it as equal to 1 minus alpha by alpha into IC. Okay, so IC by IB is equal to, or you can write IB by IC. Oh no, this is fine. IC by IB is equal to alpha into 1 minus alpha. And this particular value is called beta, or current amplification factor in common emitter. Common emitter. Current amplification in common emitter. Beta equal to alpha by 1 minus alpha. Just add alpha by 1 minus alpha plus 1 equal to beta plus 1. So this I can write it as alpha plus 1 minus alpha divided by 1 minus alpha equal to beta plus 1. So, okay, so alpha and alpha get cancelled. So 1 divided by 1 minus alpha equal to beta plus 1. This is the relation between alpha and beta. In the first one is also correct. There is no problem. This was also your previous question, I think, the relation. Now here, this is the input. IB will be input. IE will be the output. Okay. So current amplification factor, let us write it as gamma. current amplification factor, let us write gamma. So gamma will be equal to IE by IB, right? Now what is IE? IE is nothing but IC plus IB. IC plus IB is nothing but IE divided by IB. Now that I can write it as IC by IB plus IB by IB, that is equal to 1. Now what is this IC by IB? What is current IC by IB? Current amplification is common emitter, that is nothing but beta. Okay, current amplification in common emitter. So beta plus 1. Okay, so please wait, we will do with respect to IC also. So IC is equal to alpha IE plus IC naught. This value we will neglect. So IE, from that IE, this is one equation. This is another equation. IE is equal to IC plus IB. Alright, IC plus IB. So IC means 1 minus alpha into IE, 1 minus alpha into IE, this equation. IE is equal to IB. Bring this to the other side. IE minus alpha E. So 1 minus alpha into IE is nothing but IB. Okay. Now then we can write IE is equal to IE is equal to IB divided by 1 minus alpha. Alright. Now what is IE by IB? IE by IB is equal to 1 divided by 1 minus alpha. Now this is in terms of alpha, this is in terms of beta. Both are same thing. Both are same thing. This is gamma equal to 1 plus beta. Here the gamma is equal to 1 divided by 1 minus alpha. So you can equate. But we have already seen beta plus 1 is equal to 1 divided by 1 minus gamma. Beta plus 1 is equal to 1 divided by 1 minus gamma.
Now for the students, here is the greatest news. SP Academy, in association with VK Lectures, has been conducting demo classes for CSIR NET and KSET exam since 18th November 2022, which are absolutely free and any aspirant can join without any registration. Till now, around 250 members have joined our group, and interested participant can join the WhatsApp group using the link, or you can always feel free to contact us. WhatsApp group link and the contact details are given in the video description. Thank you for watching the video. Have a great day.